Hello everyone, my name is Aman and here we are going to discuss how to measure a diameter of a circle within an image. Basically this idea is taken from one IEEE paper, that is a new method of circle center and radius detection in an image processing. So let's see what all we are going to do in this presentation. These are all the topics that we are going to discuss one by one. So let's start. Why do we need to detect a circle or to measure its diameter? So the answer to that question is whenever the human eye is not able to detect a circle or to measure its size, then this concept comes really handy. Measuring object within an image can be an important capability for many other activities, applications where computer vision is required instead of making any physical measurements. So how to detect a circle within an image? In order to detect any circle, we need to first find its edges. And edges are points where there is a sharp change in color. So for detecting a circle, we need to make the background distinguishable from the circular object. We can do that by making the background lighter or darker. Once that is done, we can easily distinguish the sharp change in the color, and thus we can detect the circle by that. Here we have used a Huff transform. Huff transform is a feature extraction technique used in image analysis. It is a technique used to find the imperfect instances of objects within certain class of shapes. Like here we are using it for the circular objects. We will be taking idea from this algorithm to find the centers and the radii of this detected circle. So let's see how to find the center and radius of the detected circle theoretically. So let us assume this is the detected circle that we have found and we know the edges of that. So P1, P2 and P3 are known to us, that is x1, y1, x2, y2 and x3, y3. We'll join that and make a chord. So P1, P2 and P1, P3 are two chords. We'll perpendicularly bisect those chords and the intersection of those perpendicular bisectors are nothing but the center. So let us assume the point of P4 and P5 to be x4 and y4, x5 and y5. How to find these points? So let's see. For P4, x4 and y4 are the points and we can find through the values of x1, y1 and y1, y2. Similarly for P5 we can find it from x1, x3 and y1, y3. Since P1 and P2 is a line, so it has an equation. So this is the equation of line. Y is equal to k1x plus b1. K1 here is the slope of that line and B1 is the intercept. So we know the slopes formula, that is y2 minus y1, x2 minus x1. And here that we have taken the value to the left hand side, we'll get the B1's value. Similarly, we'll do that for another chord P1, P3. Since you can see here, these are perpendicular to each other, so the slope will be minus 1 upon the slope. So that is done over here. This is the equation of that perpendicular bisectors and this is k11, that is the slope of that perpendicular bisector, and we know the value of that, that is minus 1 by k1. So this is what it is. Similarly, we'll find b11 from the value of from the equation. Similarly, for another bisector, we'll find the slope and their intercept. Once we found the equation of that line, we know that the point where they intersect is the center. So we'll equate both the equation and we'll get the value of centers, that is x0, y0. After that, finding radius is an easy task. Just put the values into the equation and we will get the radius. So r is equal to x0, that is the center, minus any point that lies with the center's equation. So we'll get the radius from there. This is done theoretically. Let's see what all are the objectives that we are going to consider over here in this project. First, we'll find the circles within an image. Then we'll find the radius and the centers of those circles, detected circles. So let's see. This is the flow chart of all the whole process that we are going to see here. First, we'll be considering an image that is a color image. Then we'll be converting it into a grayscale image so that we can distinguish it from the background. The circular objects can be distinguishable easily if the background and that circular objects are different in color. After that, we'll be converting it into a binary image for for the detection of the centers. Once we get the center, getting radius is an easy task. So let's see. This is the implementation in MATLAB. This is the code for detecting and measuring the center and radius of a circle. First, we'll be considering an image and we'll read that image and we'll display that. After that, we'll decide some distance under which we have to detect the circle. A region, we have decided a region in which we will be detecting all the circles. Once that is done, we'll be distinguishing the circles from the background by converting the image into a grayscale version of image, and we can easily see the sharp changes, and thus we can detect the circles. After detecting the circles, we'll be finding the centers and the radii of that detected circles. Here we have made the background lighter than the objects, circular objects, so that is why we are finding the dark image over here. This is the sensitivity, how much sensitivity we require to detect the circles. Once that is done, all the images are shown. So let's see the output. So this was the original image that we have taken. After converting that image into a grayscale image, you can see the background is lighter than all the darker circles over here. And this is the detected circles, and you'll get the output at the command window, all the detected circles and their radius and centers. So why are we doing this? What are the real time applications of this project? So in medical science, whenever they want to detect a microbe which is very small in size, it is not possible for human eye to detect a circle and to measure its diameter. This concept, this project can be very useful. Also in mechanical industries, the circular shape tools can be detected very easily and can be checked whether it is proper and accurate in size. That is very much required in mechanical industries. Also in the space agencies, all the planets are in spherical shape. So once we capture that image, we can easily find the size of that planet by this method. So it is very useful in real-time applications. So if you have any other questions, do ask in the comment sections. I hope you all understood and it was very much clear to you all. Thank you.